Hello everyone and welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in 99 days. Today is day 16 and I am going to discuss previous year questions from the chapter Light, and without any delay let's start with the chapter configuration, what all we are going to discuss today. So today we are going to discuss 8 MCQs, okay, then we are going to discuss assertion and reason based questions 4, short answer type 2 marks question 5, and short answer type 3 marks questions again 5, long answer type 5 questions, and 3 case based questions from mostly some from the previous year questions. So let's start with the questions, and some questions are taken from sample question paper as well. So as you can see, SQP means sample question paper, okay. Some questions we have collected but we have not found from exactly not sure from where we have which paper, because you know that CBSE has a lot of different papers. Some questions are from Delhi board, someone is outside Delhi, so that sometimes it is difficult to determine from where these questions are from, so those we have kept blank. Now let's start. Which of the following mirror is used by dentists to examine a small cavity in a patient's teeth? Okay, so a small cavity in patient's teeth, that means it is forming a virtual image, not only a virtual image, it is also an enlarged virtual image, so that you can test how big it is, how dangerous it is, you can check inside it. So definitely only one mirror that can produce virtual but enlarged image, that is concave mirror. So obviously concave mirror is used by the dentist, okay. So maybe next time when you visit to a dentist, you ask him or her, can you please give me your mirror, I want to check. Okay, you can check, there is a small mirror, they insert it in your mouth to check your teeth, right? So this is a concave mirror. Next is, while looking at the above diagram, Nalini concluded the following. So they have given this diagram, and based on this diagram, Nalini, a student, she figured something out. What are all the things that she figured? The image of the object will be virtual. So she first figured that this is the object, image of the object will be virtual. The reflected ray will travel along the same path as the incident ray, but in the opposite direction. So reflected ray will travel along this line but in the opposite direction. Okay, the image of the object will be inverted, and this is a concave mirror, and hence the focal length will be negative. Okay, so these are the all observations. Now out of this, which observation, there is only one observation which is incorrect. Can you tell me that? So those who are saying that anything else other than 1, they are wrong. Only option 1 is incorrect. This is incorrect, because it's a concave mirror and the distance is more than focal length, so definitely it will be a real image, not a virtual image. And 2, 3 and 4 are correct options. Okay, so 2, 3 and 4 are correct, so we have to check which option 2, 3 and 4 are correct. Okay, so these are the correct options. Okay, now next question. An object is placed at a distance of 40 centimeter in front of a concave mirror of a focal length of 20 centimeter. So concave mirror, focal length of 20 centimeter and the object distance is 40 centimeter. So object is placed at C, at center of curvature, right? The image produced is virtual and inverted. No, concave mirror means it has to be real and erect, real and inverted. Okay, real and inverted of the opposite size that of the object, real inverted and of the same size as that of the object. So real inverted and of the same size as that of the object. So basically that is the meaning of that, because we have kept the object at C. So at C it is real, it is inverted and it is of the same size. Right, next question. 3 students A, B, C focused a distant building on a screen with the help of a concave mirror. To determine the focal length of the concave mirror, they measured the distances given below. Student A from the mirror to the screen, student B from the building to the screen, student C from the building to the mirror. Who measures the focal length? Very interesting question. So when we are measuring the focal length of concave mirrors or convex lenses, we generally focus a distant object such as a building, okay, or some cases sun, okay, and on the screen, and then we measure the distance between the screen and the mirror, right? Because light that is coming from the mirror are considered to be parallel. After reflection they converge at a distance, okay, but it is not 100% accurate because there is some angle involved, so they are not exactly the focal length, but you can consider this distance to be almost equals to the focal length, right? So the student A actually measured it correctly, so only A measured it correctly. Okay, student B and C, they went to the building to measure the distance, which is actually not required. Okay, and in fact it is very difficult to measure the distance using a tape or any scale, right? So you cannot measure the distance of the building and the screen, or measure the distance between the screen and the mirror, right? Because building is a far away object, so that's why we measure the distance between the screen and the mirror. Easiest way to calculate the focal length. Velocity of light in air is 3 times 10 to the power of 8 meter per second, and velocity of light in medium is 1.5 times 10 to the power of 8 meter per second. What is the refractive index of the medium? Refractive index of the medium is speed of light in vacuum or in air divided by speed of light in the medium. So 3 times 10 to the power of 8 divided by 1.5 times 10 to the power of 8, 10 to the power of 8 is cancelled, so it will be 2. So refractive index is 2. Okay, and it's a dimensionless or unitless quantity. A ray passes from air to glass in a spherical glass slab and passes through the center of the slab without deviation. Then the angle of incidence from the air to the glass at the point on the glass slab is. So there is a glass slab, but it is a spherical, there is a center, and a ray passes directly to the center without any deviation. So definitely we know that anything passes through the center. Okay, this is the angle of incidence. It is passing along the normal. So anything passing along the normal, the incident angle is 0 degree, not 90 degree. It is 0 degree. Okay, this angle we are not measuring. We are measuring the angle with the normal itself, and this thing without deviation is only possible when object is the ray of light is moving in the direction of normal, along the normal. Okay, so answer is 0 degree. Question number 7. The refractive index of flint glass is 1.65 and that of alcohol is 1.36, which with respect to air. What is the refractive index of the flint glass with respect to alcohol? So the refractive index of the flint glass with respect to alcohol is refractive index of glass divided by refractive index of alcohol. So that is 1.65 divided by 1.36, which will turn out to be approximately 1.21. Okay, so correct answer is option B. Next, question number 8. Consider these indices of refraction: glass 1.52, air 1.0003, water 1.333. Based on the refractive indices of 3 materials, arrange the speed of light through them in the decreasing order. So speed of light through them in decreasing order, that means highest the refractive index, slowest is the light. Right, we know that refractive index sometimes also gives you the optical density. Okay, so optical density, denser the medium, slower is light. So for glass light is moving slowest. Okay, decreasing order means first we have to mention the maximum one. So speed of light in air, then definitely water, and at last it will be glass. Higher the refractive index, slower is light. Okay, and decreasing order means first you have to write the highest value, then will be the last value. Okay, so as you can see, only one option has this correct answer: speed of light in air, speed of light in water, speed of light in glass. Okay, in fact if you just know one portion, that obviously light is almost equal to the speed of light in air is almost equal to that of in vacuum, that's why its refractive index is considered 1. you can answer this, because only one option has correct answer. Starting answer is first, that is speed of light in air, that is the first option. So you can answer this easily, that obviously air, for air the speed is maximum. So other options all started not with air, but twice with glass, once with water, so definitely they are not correct. Next question number 9 is a assertion and reason based question. A plane mirror may form a real image. A plane mirror forms a virtual image if the object is real. Okay, so a plane mirror may form a real image is partly correct, not 100% correct. It's for a virtual object, plane mirror can form a real image. Okay, so both are correct option. Obviously for real images, a plane mirror will obviously form a virtual object, okay, virtual image. So both assertion and reason is correct, but reason is not the correct explanation for the assertion. Okay, question number 10. Now you can debate on this question, but this statement is true. Okay, this is a correct statement. A real image, a plane mirror can form a real image for virtual objects. Okay, if the object is virtual, now you might say, sir, how can object be a virtual object? So for example, you have a plane mirror like this, just for to give you a comprehension. So there was some light rays coming like this. Okay, they were about to converge here. If the mirror was not there, then they would have converged here. So this is called a virtual object, and after reflection they will form a real image here. Okay, excuse me. So this is a virtual object, this is a real image. So a real plane mirror can produce a real image based on certain condition. Okay, now a real image is always formed by the actual convergence of light rays at some point. Okay, yes, correct. A convex mirror always forms a image, I think a real image. Okay, both assertion and reason are correct. No, reason is false. Convex mirror cannot produce real image, it can only produce virtual image, but assertion is correct. So assertion is true and reason is false, so reason is false. Next question number 11. Assertion is, if rays are diverging after emerging from a lens, the lens must be concave. Okay, so the rays are diverging after emerging from a lens, the lens must be concave. The convex lens can give diverging rays. Yes, convex lens can give diverging rays. If the object is placed less than focal length, then definitely a convex lens can produce a diverging rays. So this assertion is obviously not correct. Yes, if the rays are diverging, it can be concave lens, because concave lens always produces diverging rays, but convex lens can also produce diverging rays. So both the lenses can produce diverging rays. So you cannot say if the rays are diverging, it is only coming from a concave lens, right? So reason is correct, assertion is false, so option D is correct in this case. Question number 12. A refractive index of glass with respect to air is different for red light and violet light. Okay, refractive index for a glass is obviously different for red light and violet light. It depends on the color. Okay, we know that it depends on the medium, it depends on the color. Refractive index of pair of media depends on the wavelength of light used. Yes, it depends on the wavelength of light used. So both assertion and reason are correct, and the reason is correct explanation, because we know that red light and violet light, they have different wavelength, right? Different wavelength of light means they will have different wavelength refractive index. So reason is correct obviously, and it actually explains the assertion. Okay, so both A and R are correct. Now next, 2 more question. This is outside Delhi set. The absolute refractive index of ruby is 1.7. Find the speed of light in ruby. The speed of light in vacuum is 3 times 10 to the power of 8 meter per second. So we know that refractive index is given by speed of light in vacuum divided by speed of light in the medium. If you have followed my class yesterday, I discussed it. So V equals to C by N. Okay. So it is 3 divided by 1.7 times 10 to the power of 8. Okay, so it will be about 1.8 times 10 to the power of 8 meter per second. Okay, it will not be exactly equals to 2, because if it is 1.5 then it would have been 2. It will be slightly less than it is slightly less than 2. It will be around 1.8, 1.9. Okay, 1.8 is very good approximation. Okay, very simple answer. If you write this formula and write this answer, you will get full marks. Don't worry. Okay, the power of a lens is plus 5 diopters. What is the nature and focal length of this lens? So plus power means it is a convex lens. We know that power of a lens is given by 1 by f, when f is expressed in meters. If it is a centimeter, then you have to write this as 100. Okay, now because power is positive, that means focal length is also positive. Focal length positive means it is a convex lens. So nature is convex lens. Okay, and focal length of this length is f is equal to 1 by p. Now this is in meters, so what we will do, we will divide by 100 by 5 in centimeter. This is in meters. Okay, 1 by p, if you just do 1 by p, you will get in meters. But 1 by meter, it will be very small value, so we will convert that and we will get, it will be 20 centimeter. Okay, focal length is equal to 20 centimeter. Okay, now what is the next part? At what distance from this lens should an object be placed so that to get inverted image of the same size? So inverted image of the same size means the distance will be that of the twice of the focal length, that is 2 times 20, that is 40 centimeter from the lens. So from if we place an object 40 centimeter from the lens, we will get an image of the same size at the object but inverted, right? So this is the rule. Next is an object of height 10 centimeter is placed 25 centimeter away from the optical center of a converging lens. Converging lens means convex lens. Okay, in general converging lens we refer this as convex lens, even though the convex lens can produce rays that is diverging, but most cases, 90% cases, it produces converging rays. So that's why we say it's a converging lens. Okay, so convex object of height, so height of the object is 10 centimeter. Okay, placed 25 centimeter, so u equals to, and we always say that take u as negative value, right, because we are using the lens equation to calculate it. Center of a converging lens of focal length 15 centimeter. So converging lens means focal length is positive, that is 15 centimeter. Okay, calculate the image distance and height of the image formed. So we will use 1 by v minus 1 by u equals to 1 by f. Now when you are using this formula, don't forget to use the sign. Sign is very, very important. Without sign you will not be able to solve this properly. So minus 25 equals to 1 by 15. So 1 by v equals to 1 by 15 minus 1 by 25. So this minus will cancel here, so this will go to the other side and it will become another minus, right? Now what is the LCM? 25 and 15 LCM will be 75. Okay, 75 means 3 15s are 75, sorry 5 15s are 75 and 3 25s are 75. So 5 minus 3, so it will be 2 by 75, or V equals to 75 by 2, so it will be 37.5 centimeter. Okay, now what is the magnification in this case? Magnification is modulus of the magnification is V by U. What is the meaning of modulus? Modulus means we will not consider the sign. Okay, we are only interested in the final height of the object. We are not interested in the orientation. So if you put the negative value of U, V is positive, that means it is on the other side of the lens, right? So basically what you will get an inverted image. It's a real image, so you'll get an inverted image, but we are not interested in that. So 37.5, instead of writing 37.5, what we will write? We will write 75 by 2 divided by 25. That will be easier for us, nothing else. So you will get 325 is 75, you will get 3 by 2, that is 1.5. This is the magnification. So what is the final size of the object, final size of the image? It will be magnification times the height of the object, so that is 1.5 times 10, that is 15 centimeter is the height of the object. Okay, so the answer is V is 37.5. it's a real image. Okay, so it's a real image. Can you tell me what else tell us that this image is real? Mention that in the comment below. I am saying this is a real image. Okay, so what else tells us that this is a real image? I will not tell you the answer here. Maybe in future if some question comes I will explain, but otherwise I will not explain that. You have to mention that in the comment below. So I am saying that from this value you can say this is a real image. Why I can say this is a real image? Next question. An object is kept at a distance 1 meter from a lens of power 2D. So as you can see, most of the questions from this chapter are based on some numerical concepts. Okay, and maybe some numerical concept. Based on the numerical concept, they will ask you to draw a diagram, they will ask you some explanatory questions, but other than that all the questions require some numerical knowledge to solve questions. Okay, this is from set 2 Delhi 2023. An object is kept at a distance 1 meter from a lens of power 2D. So power of the lens is 2D. Identify the type of lens. It is a convex lens. Again, as I said, power plus means convex lens. Calculate its focal length and distance of the image formed. Okay, so here object distance is 1 meter. So first of all we have to calculate the focal length. Focal length is 100 by power in centimeter. Okay, 100 divided by 2, that is 50 centimeter. Okay, 50 centimeter is the focal length. Okay, calculate the focal length and distance of the image formed. So distance of the image formed, say V. Okay, and what is U? F is 50 positive. Okay, for convex lens 50 centimeter is positive, and object distance is minus 1 centimeter. Okay, object distance 1 meter. Eraser. So it's 1 meter. 1 meter means what? 1 meter means 100 centimeter. Okay, so U is 100 centimeter. So 1 by minus 100 plus equals to 1 by 50. Okay, or 1 by V equals to 1 by 50 minus 1 by 100. So what is LCM? LCM is obviously 100. Easy to calculate. 2 minus 1. So 1 by V equals to 1 by 100, or V equals to 100. So we may not need to solve this question, because if we realized the fact that U is actually 2F, then we could have said that U is 2F, so V will also be 2F, but on the other side of the lens. Okay, because it's a lens, so it will be on the other side, it's inverted, same size of the object. Okay, so we have calculated convex lens, focal length is 50 centimeter, and object distance is 100 centimeter or 1 meter. Okay, it will be 1 meter as well. Now question number 17. A 10 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 12 centimeter. Convex lens of focal length 12 centimeter. Let me write it immediately as soon as I see this. Okay. The distance of the object from the lens is 18 centimeter. Distance is 18 centimeter. Object distance will always be negative. As soon as you realize that whenever you are writing object distance negative, your life's 50% problem will be solved. Okay, find the nature, position and the size of the image formed. Okay, object height of the object is given also 10 centimeter. We will use that as the last step. It is required last step. First we will have to find the location of the image. Okay, there is no direct relationship. So 1 by V minus 1 by minus 118. Always check one thing before doing anything, that if the object distance is double that of focal length. If object distance is double that of focal length, okay, then your 99% problem is solved. Then you can directly write V is also double that of focal length, size, height, etc. will be 1. Okay, magnification will be 1, whatever size of the object, same size of the image as well. Okay, so here it is 1 by 12, but in this case unfortunately we have to do the mathematics, no other options. 1 by 12 minus 1 by 18, so it will be LCM is 18, no, not 18, 36. LCM is 36. Okay, 3 12s are 36, 18 2s are 36, so it will be 1 by 36. So V is 36 centimeter. Okay, so from this we can say that answer part, what are all the answers here? So first question is find the nature. So from this, what is the nature? Nature is real image. As I said in our previous case, how can I say from the value of V that this is a real image? V is positive. So V is positive in case of a lens. So if the V is positive in case of a lens, then the image is real. If V is negative in case of a mirror, then image is real. Okay, so there is a slight changes in case of mirror and lens. If V is positive for lens, okay, it is a real image. Okay, so first of all, nature is real, because so first nature is real. Okay, so we also calculated V equals to 36 centimeter. U was given as minus 18 centimeter, right? So nature is real, then real and inverted. Real image definitely means it's an inverted. Also sign of U and V are opposite, so this is an inverted image. Next is position. Position is V equals to 36 centimeter on the other side. Okay, next is size of the image formed. To find the size of the image formed, you have to calculate the magnification. Magnification is V by U. So V is 36. We again ignoring the sign, because we are only interested in the size, final size. Okay, if they ask you with sign, then only you need to use negative sign in case of magnification. So the height of the image is 2 times height of the object, that is 2 times 10, that is 20 centimeter. Okay, so height of the image is 20 centimeter. Okay, so I hope this helps. Next, if you are still confused about your future, what to do in future, what type of problems you are most fond of, okay, maybe you are suitable for to become a doctor in future, maybe you are suitable to become an engineer in future, but you don't know, and you are confused what to study after my 10th is over. Because after 10th is over, it is very important to choose your stream, very important to streamline your education. So if you are still like that, one of them, and if your parents are also confused, then definitely you should attempt Diksha Scholastic Aptitude Test, that is DSAT, every Sunday in our Diksha campuses. Every Sunday we are conducting DSAT. Here you will be given a 1 hour lecture. Okay, after the lecture is over, there will be a doubt clearing session. Once the doubt clearing session is over, based on the lecture, the knowledge that you acquired, there will be an 1 hour test. Okay, and after the test is over, based on the test result, there will be a one-on-one counseling to you, which is very helpful for your career, your future. They will ask you, they will tell you what is suitable for you, whether you should become an engineer or whether should you become a doctor. Okay, or you should not choose science at all, you should move for commerce or arts. So every guidance will be given to you, and if you want, you have to fill this form. The link of the form is given in the description below. Fill the form, our representative will contact you, they will guide you. This part, filling of the form, is absolutely free of cost. Okay, and our representative will guide you about the cost of the DSAT test, etc. But if you are still confused, you can just try it once, right? There is no harm in trying. You try a lot of things in life, and many of the things fail, so you can try at least once, and then you see if you want to opt for it or not. Okay, now let's move on to the type 4 question, that is a short answer type 3 marks question. Power of a lens is plus 4d. Find the focal length of this lens. An object is placed at a distance of, so 3 marks, 2 marks question are almost similar. So as you can see, they are almost similar, only maybe a little bit more extra steps will be there. Other than that, there is not much difference between 2 marks and 3 marks question. The power of the lens is given. Power is obviously plus 4d. Okay, so find the focal length of the lens. Focal length, we know that focal length is 100 by d in terms of centimeter. So when you are using this, you have to use this unit here. Okay, if you are using 1 by p, then you have to use the unit of meter there. Okay, so 100 divided by 5, okay, 20 centimeter. Sorry, my mistake. It is not 5, it is 4. So it will be 25 centimeters. So focal length is 25 centimeter. Okay, an object is placed at a distance of 50 centimeter. So u equals to minus 50 centimeter, but as you can see from this, u is basically 2f magnitude wise. Without symbol, if you ignore the sign, then u is equals to 2f. So first of all, v will be also 2f, that is 50 centimeter. Without any single calculation, without using any single formula, we have determined that image will be located at 50 centimeter on the other side of the lens, that is a real image. Okay, from the optical center of this lens, state the nature and magnification of the image. Nature is real and inverted. Okay, magnification equals to 1, because when the object is placed at 2f, we obtain an image exactly at 2f on the other side of the lens, and magnification is 1, right? So magnification of the image is 1. And also draw a ray diagram to justify your answer. So in case of 3 marks question, they have asked you to draw the ray diagram. So if you have followed my class yesterday, I gave you an advice how we can draw the ray diagram. Okay, in this case, focal length, okay, 2f, then you draw this arrow. Okay, this is focal length. Oh, okay, so in this case, as I suggested, you measure this length, and at this point you draw a arrow of the same height. Okay, so that you don't make any mistake. So you have to draw the same arrow here. Okay, now you join this point. Okay, this will be almost your focus, and next point will be you have to pass it through this. Okay, if you use your scale, then it will be almost through this point. Don't worry too much about it, but this should be equal. This is a back tracing method, obviously back calculation method, where you are doing back calculation to match your answer, because you know this is the correct answer. And remember that when they ask you to draw the ray diagram and the distances are 25 centimeter, 50 centimeter, actually you don't need to draw the diagram of 25 centimeter. Very, very important. Okay, if they say that focal length is 100 centimeter, how can you draw 100 centimeter in your exam book? That is not possible. It will be a representative diagram. As I said, it will be a representative diagram. You don't need to show exact focal length of this. 25 centimeter is quarter of a meter. So that will be very big. Okay, if you show the focal length, your paper will be over. You will never be able to draw 50 centimeter in your notebook, right? So it is not possible. So don't try that. Okay, only if you want, you can reduce it by 10 times, so you can show 2.5 centimeter and 5 centimeter. That is fine, that is up to you. But in any case, if you do not make anything like that also, that is fine. Okay, if you take the focal length arbitrarily on your own assumption, but only thing that matters is this length should be double of this length. Okay, my scales are not exactly perfect, so but you should be careful that this distance, whatever distance you are taking, should be double of that. Okay, that is more important. Next, a ray of light skirting from a diamond is incident on the interface separating diamond and water. Okay, draw a labeled ray diagram to show the refraction of light in this case. Absolute refractive index. So this part I am leaving it to you. You can try, you can search the answer in your book. Okay, diamond is like this. Okay, you have to show the diagram. I am not drawing the diagram. I am not expert in drawing diagrams, especially like this. Okay, you can try and search this diagram and draw it, but I will solve the next part. Absolute refractive indices of diamond and water are 2.43, 42 and 1.33 respectively. Find the value of refractive index of water with respect to diamond. Very interesting question. So here we have to find the refractive index of water with respect to diamond. So refractive index of water with respect to diamond is refractive index of water divided by refractive index of diamond. So it will be 1.33 divided by 2.42, so approximately 0.5. Approximately 0.5. Okay, not exactly, but approximately 0.5. So as you can see, refractive index can be less than 1, but this is only relative refractive index. Absolute refractive index cannot be less than 1. Okay, but relative refractive index can be less than 1 based on which two medium you are considering. Okay, next is water has a refractive index 1.33 and alcohol has a refractive index of 1.36. Which of the two medium is optically denser? Give reason for your answer. So as I said, whoever has the higher refractive index is optically denser. So basically in this case, alcohol is optically denser. Alcohol is optically denser because it has higher refractive index. Okay, draw a ray diagram to show the path of ray passing obliquely from water to alcohol. Okay, so from water to alcohol, so we have, suppose we have a tank here. So alcohol in general is lighter than is heavier than water, so it generally sinks. Okay, so suppose we have this is water, this is alcohol, this is water, this is alcohol, and ray of light is coming here. As the ray is incident on this, okay, so as you see, the difference in refractive index is not too much, but it is still more. And as the ray of light traveling from denser rarer to a denser medium, it will bend towards the normal. okay, so it will bend but not super bend, okay, you barely realize that there is a bend, okay, but there will be significant bending if for higher angle of incidence, so you have to show the bending, okay, you have to show the bending, but the bending will be small, okay. State the relationship between angle of incidence and angle of refraction in the above case. So angle of incidence, suppose this is angle of incidence, this is angle of refraction, so sin I by sin R is the refractive index of the second medium with respect to the first medium, right? Sin I by sin R is the refractive index of the second medium with respect to the first medium. So refractive index of alcohol with respect to water, okay, you have to remember that refractive index of alcohol with respect to water. So when light is traveling from air to water, we measure the refractive index of water, right? Similarly, in this case, light is traveling from water to alcohol, so refractive index of alcohol with respect to water, so it will be refractive index of alcohol divided by refractive index of water. So 1.36 divided by 1.33, it will be 1.01. okay, so the value of I and R will be almost same but not exactly same, okay. Now next question, a light ray enters from medium A to medium B, okay, light ray entered from medium A to medium B as shown in the figure. Which one of the medium is denser, that is with respect to other medium? Justify your answer. So now you can see that a light ray is traveling here to here. So as light ray here, angle of incidence suppose is I. Here the angle of refraction is R. Now which one is greater? I is greater or R is greater? So from the figure it is clear that I is greater than R. So angle of incidence is greater than angle of refraction, and this happens because speed of light in medium A is less compared to speed of light in medium B. As the speed of light decreases in medium B, it bends towards the normal. So speed of light in medium A is more, speed of light in medium B is less, and less the speed of light in medium, denser it is, okay. So but you cannot write like this in your exam paper. So what you will write, you will say since the ray of light after diffraction bending towards the normal, so medium B has higher refractive index compared to medium A, so we can say that medium B is optically denser compared to medium A, okay, because higher refractive index. So say NB, here NA, so you can say because sin I is equals to greater than sin R, we can say that NB is greater than NA, so medium B is optically denser compared to medium A, okay. So remember that if someone is denser, optically denser, the angle will be less. Angle for a denser medium will be less, be it incident angle, be it refracted angle, okay. If you pass this in this direction, suppose the ray of light is going from here to here, okay, so in that case incident angle will be less compared to refracted angle, right. So optically denser mediums will always have less angle in that medium compared to optically rarer medium. You have to remember this short form. If the speed of light in medium A is VA, okay, speed of light in medium A is VA, okay, and medium B is VB, what is the refractive index? What is the refractive index of B with respect to A? Okay, so first, as we know, refractive index of a medium, say refractive index of B with respect to A is given by speed of light in B, speed of light in A divided by speed of light in B. Okay, first is incident medium, second is refracted medium. Okay, so this is the formula for refractive index. Next question. A student holding a mirror in his hand directed the reflecting surface of the mirror towards the sun. He then directed the reflected light to a sheet of paper held close to the mirror. What should he do to burn the paper? So he is burning the paper. So he has a mirror, he has a paper, sun rays are falling on it, okay, and what he is doing, he is directing them to a paper. Okay, so what he should do, he should try to adjust the mirror so that a very small dot is formed on the paper. This small dot is nothing but an image of the sun. Okay, so sun is huge and you are trying to form that image on the paper, and that is why it is getting burned. So that small dot, when you focus by using a lens or using a mirror, whenever you focusing on the paper, then basically what you are doing, you are forming an image of the sun on the paper. Okay, so you have to adjust, the answer should be for that, he has to adjust the mirror so that a small tiny dot is formed on the paper. Okay, which type of mirror does he have? So obviously, since he is able to focus it, so this is a concave mirror. Okay, next, will he be able to determine the approximate value of the focal length of this mirror from this activity? Give reasons and draw ray diagrams to justify your answer. In this case, ray diagram I have already drawn. Okay, and as you can see that because the rays are converging here, if you measure this distance, this gives you almost approximate focal length of the mirror. Okay, because for parallel rays we know that if this is a parallel rays falling on a mirror, after reflection they all focus at a single point. You can draw this like draw this diagram like this as well. Okay, whatever you are comfortable with. Okay, but you generally use it a large paper, and this is more accurate, this is more theoretical. Okay, this is more theoretically correct. Okay, this distance is f, whereas this is more practically correct. Okay, both diagrams I think will be fine. Okay, question number 23. Now we are entering into long answer type questions. Draw a ray diagram. So a lot of drawings are there. If the drawings are similar, I will not draw each and every diagram. I will just give you a hint. Okay, and I will draw it quickly. I have already explained how to draw ray diagram for mirrors, for lenses in my regular classes. If you don't know, you can go and check that lecture. Okay, draw a ray diagram in each of the following cases to show the formation of image when the object is placed between optical center and principal focus of a convex lens. Okay, so a convex lens, optical center and principal focus of a convex lens, if you place it, you will obtain a virtual image. So this is f2. So first there will be a ray which is passing through the optical center. Second, if you trace them backwards, they will interfere somewhere and you will get an image. So this is a virtual image. Okay, anywhere in front of a concave lens. Okay, anywhere in front of a concave lens. So you can place it anywhere. Actually this is f2. So after refraction it appears to come from here, goes in this direction, and one ray, this is true for both convex and concave, so this will go here and you will get an image here. This is the anywhere of the front of a concave lens. At 2f of a convex lens, state the signs and values of the magnification in the above mentioned cases 1 and 2. So what is the signs and values of magnification? Sign is plus here, and it is magnified. Here also sign is plus. Plus means what? Plus means erect. Okay, plus means erect. So plus, and it is not magnified, it is diminished. This diagram I have already completed once. Okay, so if you place it at 2f, image will be exactly at 2f on the other side, and the magnification will be -1, exactly -1. Okay, you can write the value for option number 3, question number 3, because it is inverted, it is same size, and it's real. So -1 will be the magnification for case number 3. Okay, this is case number 2. This is case number 1, obviously. Okay, now question number 24. An object 4 centimeter in size is placed 25 centimeter in front of a concave mirror of focal length 15 centimeter. Okay, so object height is 4 centimeter. Okay, placed 25 centimeter, u is -25. U is, remember, for no matter whether it is a lens or a mirror, the image distance, object distance will always be negative. Okay, next is what? Focal length is 15 centimeter. Now concave lens, so focal length will be negative. Okay, now at what distance from the mirror should a screen be placed in order to obtain a sharp image? So basically they have asked you find the image distance. Instead of asking it politely, they have asked you indirectly where you should place a screen to find the sharp image. Ask simple questions. You guys are not stupid, right? They could have simply asked for find the object distance, find the image distance, but instead of asking that, they have said where you should place a screen to find a sharp image. Okay, so basically they have a lot of printing energy, so they have told you how to calculate it, right? So 15, it will be minus plus 1 by 25. LCM is 75 as usual. So -5 plus 3 will be minus 2 by 75, or V equals to 75 by 2, that is minus 37.5 centimeter. So you have to place the screen at a distance 37.5 centimeter from the mirror to obtain a sharp image, right? Next, find the size of the image. So what is the magnification? Magnification is minus V by U for a mirror. Again, you can ignore the sign. It will be negative, so inverted, because real image, so it is an inverted image. Okay, so it will be 37.5 divided by 15. So it will be 1.5. Okay, I have already solved it once in case of a lens problem, so I am also using the sign only, so you can check. You will get 1.5 only. Okay, next, draw the ray diagram to show the formation of image in this case. So ray diagram will be fine. Magnification is 1.5, so size of the image will be magnification times height of the object, so 1.5 times 4, that is 6 centimeter. And you can draw the ray diagram. Okay, ray diagram will be, focal length is 15 centimeter and center of curvature will be 30 centimeter. Object is placed 25 centimeter, so it will be between C and F. Okay, so for this, how to draw? First you can take this ray, so this ray will go along this only, and you have to extend it in this case, and this will be, after this they will intersect like this, so you will get an enlarged inverted real image. So, and remember that for ray diagram, arrows are must. So this is the diagram. Okay, simple diagram, only using your pencil, scale, compass, you can draw it, not super difficult. Next question, 25. Okay, an object is placed at a distance of 60 centimeter from a concave lens of focal length 30 centimeter. So object is placed at a distance of 60 centimeter from a concave lens of focal length 30 centimeter. So remember that this is a concave lens. Even though the distance is 60 centimeter, does not matter. So focal length for a concave lens is negative 30 centimeter. And object distance is negative 60 centimeter. Okay, use the lens formula to find the distance of the image from the lens. So you have to use the lens formula 1 by v minus 1 by u equals to 1 by f. Now remember, if you are not using proper sign, okay, what can happen is you wanted to find it for a concave lens, but you get it for a convex lens. Okay, so everything will be massacred if you are not using proper sign convention. Sign convention is very, very, very important. Minus 1 by minus 60. Okay, there are multiple different sign conventions was there, but this is the modern sign convention adapted. Okay, USA people, they use some complete different sign convention, but don't get bogged down by them. Okay, you are not studying in USA, you are studying in India, so you will use whatever most common sign convention. Okay, negative sign is common, so 60 is the LCM. 2 plus 1, so minus 3 by 60, so it will be 1 by 20, or v equals to minus 20 centimeter. Okay, so find the formula. It is v is equal to minus 20 centimeter, that is same side as the object. Okay, and it is virtual image. So list 4 characteristics of the image. Okay, nature, position, size, erect, inverted from the lens. So first of all, it's a virtual nature. Nature is virtual. 4 characteristics they have asked. Nature is virtual. Okay, next is position. Position, even though position is not a characteristic, but you can mention it is on the same side. Okay, so if they ask you to find the characteristics, you cannot simply write the value of the position. Value of the position question is already done in part A. Here you have to mention which side of the mirror. Okay, it is on the same side as the object, on the opposite side, or behind the mirror. So you have to mention that in this case. Okay, sorry. Yes, concave lens, right? Concave lens. I was confusing between convex mirror and concave lens. Yes, concave lens means on the same side as the object. Okay, not behind the mirror, obviously. On the other side of the lens means it's a real image. In this case, this is same side as the object, so definitely it's a virtual image. Okay, next is size. Size, as you can see, M, you can show that, or you can write it directly. Size is diminished. Okay, v is less than u, so definitely it will be diminished. Okay, erect or inverted, it is erect. Erect or inverted, it is erect. Okay, why erect? If you calculate m, you will get the value of m to be positive, v by u. So v is minus 20, u is minus 60. So if you use the sign here, I am using the sign here, so m is 1/3. So m is plus 1/3. M is plus 1/3 means it's an erect image, right? And it's a diminished image because value of m is less than 1. Okay, draw a ray diagram, justify your answer. For part 2, I have already done for concave concave lens in 2 questions back. You can check that. I am not going to draw same images again and again. Next. An object is placed at a distance of 30 centimeter from a concave lens of focal length 30 centimeter. Again, concave lens. Okay, here they have asked you to the distance of the object is 30 centimeter, and from the concave lens the focal length is 30 centimeter. Okay, use the lens formula to determine the distance of the image from the lens. Okay, list again same question, similar question. Okay, so as you can see, this is set 1 question. Okay, this is set 2 question. And in this case, something is interesting. First part I am doing, second part is same, but first part is interesting. Let me show you. So in this case, u is minus 30, f is also minus 30. Okay, so what will be v? 1 by v minus 1 by u equals to 1 by f. Let me put the values. 1 by v minus 1 by minus 30, okay, equals to 1 by minus 30. Okay, so 1 by v plus 1 by 30 minus 1 by equals to minus 30. Okay, so v1 1 by v equals to minus 1 by 30 minus 1 by 30. Okay, so this is not like concave mirror, convex lens, sorry. So where you get it is to be infinity. Okay, this does not happen in this case. This is quite acceptable for concave lens or convex mirror. Okay, even if you put it exactly at focus, the image is not at infinity. Image is somewhere between the optical center and the focal length. Okay, so in this case half of that. So basically you will get at a distance f by 2. That's why I said this is interesting. Other than that, all the properties, all the questions, everything is same, because it's a different set. So same question, only slightly different value. Okay, now question number 27. A 6 centimeter tall object is placed perpendicular to the principal axis of a concave mirror of focal length 30 centimeter. The distance of the object from the mirror is 45 centimeter. Use the mirror formula to determine the position, nature and the size of the image formed. Also draw the level diagram to show the image formation in this case. This question is also a similar question, but this is a set 3 question. And instead of lens they have used mirror in this case. Okay, so what is the question? 6 centimeter tall, height is 6 centimeter. Okay, concave mirror, focal length of concave mirror is minus 30. Okay, the distance of the object from the mirror minus 40 centimeter. Okay, they have asked you to find the 45 centimeters, sorry, 45, right? So they asked you to find the image distance. Okay, so 1 by v plus 1 by u equals to 1 by f. So be careful what formula to use for lens, what formula to use for mirror. There is a negative sign for lens, for positive sign for mirrors. So 1 by v equals to 1 by f minus 1 by u. I am just showing you some another way of solving. Okay, so 1 by f is minus 30 minus 1 by u is minus 45. Okay, so it will be minus 1 by 30 plus 1 by 45. Okay, now what will be the LCM of these things? Very interesting. Okay, if you see 45 is 3 into 15. Okay, and 30 is 2 into 15. Okay, so if you do the LCM, it will be 2 into 3 into 15. You can multiply it. 6 times 15 is 90. That is fine. Okay, or you can keep it like this. Okay, whichever you are comfortable with. You can do the old fashioned way, or you can do it a little bit newer fashioned way. Okay, so minus 30 is 3 3s are 30 plus 2. So minus 1 by 90. So v equals to minus 90 centimeter. Now this is a mirror. So mirror means V is negative, means it's a real image, okay, or exactly opposite from that of lens, and obviously it's a concave lens, concave mirror. So definitely the distance is more than focal length, so it will give you a real image. So in this case, V negative has nothing to do with the virtual image, it's a real image. Magnification for mirror is minus V by U. Okay, so you can calculate the magnification as well. 90 minus divided by 45, both are negative, so cancel, so it will get minus 2. So magnification is minus 2. Okay, so you can calculate whatever way you want. Okay, also draw a level diagram. Concave mirror I have already drawn, not going to discuss now. Case based question. Okay, so this is the very difficult questions which students find it difficult to answer. So some story sometime is given, some perspective is given. One such question was that student was performing an experiment using the mirror. So similar type of questions are also called case based question. Only difference is long answer type question contains 5 marks, case based question contains 4 marks. Okay, that is the only difference. Some questions are actually overlapping with each other. A security mirror used in a big showroom has a radius of curvature 5 meter. Okay, so basically they have given you some case. Security mirror in a huge showroom. Okay, radius of curvature is 5 meter. So radius of curvature is given 5 meter. Now what type of mirror do we use in security room? That is the perspective of this question. If you know that, you can answer this easily. So in security mirror we use convex mirror. Okay, so this is a convex mirror, so radius of curvature will be positive. Okay, if a customer is standing at a distance of 20 meter from the cash counter, find the position, nature and size of the image formed in the security mirror. So distance is 20 meter. Now everything is meter, no need to convert it into centimeters, right? So we know that from mirror equation 1 by V plus 1 by U equals to 1 by F or equals to 2 by R, right? So here R is given, so we don't need to use this, so we will bypass it using this. So 1 by V plus 1 by 20 equals to 2 by 5. Okay, or 1 by V equals to 2 by, so this is negative, sorry, 2 by 5 plus 1 by 20. Okay, this is negative because U is negative, always U is negative, object distance is always negative. Now what is the LCM? 4 5s are 20, so it will be 8 minus plus 1, so 9 by 20. Okay, so V is equal to 20 by 9, almost equals to 2 point something. Okay, 2 point, in fact 2.2. Okay, so 2.2 meter. Okay, so size of the image, nature is virtual, obviously, because it's a convex mirror. We know that in shopping malls we use convex mirror to observe all the corners. It has a large viewing area. I have explained during my application part, right? So find the position, nature is virtual, position is 2.2 meters. Okay, image formed in the security mirror. Size is, so magnification is 2.2 divided by 20 almost equals to 1 by 10, almost equals to 1 by 10. So the size is so they have not given you the size of the object, so size will be 1 by 10th times. Actually it will be 1 by 9th times. Okay, because 20 by 9 is there, so if you take it, it will be 1 by 9th times. Okay, if they have given you the height of the customer, then you could have find the size of the image as well. Now next, Neha visited a dentist in his clinic. She observed that the dentist was holding an instrument fitted with a mirror. State the nature of this mirror and reason for this use in the instrument used by dentist. So I already explained that the dentist uses a concave mirror. Concave mirror produces an enlarged image, right, for object which is closer to the focal length. Virtual enlarged image when it is kept at very close distance, right? So for dentist uses it very close to your teeth and just angles it so that he can see the enlarged teeth, where the cavity is, where the problem is. So that is why concave mirror is used when a dentist in a dentist mirror. So basically it's a concave mirror. Next question. Rishi went to a palmist to show his palm. The palmist used a special lens for this purpose. So if you visit a palmist, they will use a lens to read your palm. They will say, okay, your future is bad, your future is coming to be very good, but we will discuss that in a while. Here what is the question? State the nature of the lens and reason for its use. It is a convex lens. And why it is used? Because again it produces virtual images, enlarged virtual images, also called magnifying lens, right? Because it has the property, when the object is placed less than focal length, it produces a magnified image. Okay, where should the palmist hold the lens as to have a real magnified image of an object? So to get a real magnified image, the palmist should hold it between f1 and 2f1. So between the focal length and twice of the focal length, the palmist should place the lens to obtain a real image. Okay, we know that real image is formed when the object distance is more than f, but magnified real image is formed when the object is between f and 2f. Okay, if it is less than f, then it is a magnified, but it is a virtual image. If it is more than 2f, then it's not magnified, it's a diminished image. Okay, if the focal length of this lens is 10 centimeter and the lens is held at a distance of 5 centimeter from the palm, so this will be f and 2f. Okay, you can mention first primary focus and twice of the first primary focus, that is also fine. F and 2f is also fine. If the focal length of this lens is 10 centimeter, so focal length of convex lens is 10 centimeter, it is positive. Okay, and if the lens is held at a distance of 5 centimeter, so u is minus 5 centimeter. Okay, use the lens formula to find the position and the size of the image. So we have to find v. Okay, 1 by v minus 1 by u equals to 1 by f, or 1 by v equals to 1 by f plus 1 by u. Okay, now put the values. 1 by 10 plus 1 by minus 5, so it will be 1 by 10 minus 1 by 5. So it will be 10 is LCM, 1 minus 2, so minus 1 by 10. So V will be minus 1 by 10 centimeter. So you will observe an image forming at minus 10 centimeter from the mirror. Okay, from the lens, right? Easy. That is on the same side as the object. Behind the object, if they ask you to draw a ray diagram, you can solve this. Now this question is very common question. Okay, first, students took 3 concave mirrors of different focal lengths and formed the experiment to see the image formation by placing an object different distance with these mirrors as shown in the following table. List 2 properties of the image formed in case 1. In which of the cases given in the table mirror will form a real image of the same size and why? Okay, so first of all, list 2 properties of the image formed in case 1. So case 1, let's check all the cases one by one. Object distance is 45 centimeter, focal length is 20 centimeter. Okay, and they are all concave mirrors. Concave mirrors means if the distance is more than focal length, it will produce real image. Right, here as you can see, the distance is more than the radius of curvature. If 20 centimeter is the focal length, then radius of curvature is 40, right, twice the focal length. So it is more than the radius of curvature. So the image formed will be real, inverted and diminished. Okay, real, inverted and diminished. You can write any two properties, real and inverted will be fine, real, inverted, diminished will be fine. Okay, in which one of the cases given in the table the mirror will form a real image of the same size and y? So real image and of the same size when the distance is equals to radius of curvature. So in this case, as you can see, radius of curvature is 30, so this is equals to radius of curvature. So in this case u will be equals to v and magnification will be equals to 1. So in the case 2, the mirror will form a real image of the same size, okay, because distance is equals to radius of curvature. Okay, name the type of the mirror used by dentists, give reason why they use such type of mirror. I already explained that in our previous problem. Okay, because this is a concave mirror and they produce enlarged image, right? Question number C, look into the table and identify the situation, object distance and focal length which resembles the situation in which concave mirrors are used as a shaving mirrors. Draw a ray diagram to show the image formation in this case. So question number C is slightly difficult than this. So basically they asked you to identify the option C as the shaving mirror, because in this case the U is less than focal length. So U is less than focal length means it will produce a virtual enlarged image. So that is basically the reason why dentists are using concave mirrors. Okay, and they also asked you to draw the ray diagram for that. Okay, so you have to draw the ray diagram. I think I have drawn this once. Let me draw once more. This is C, this is F. So this is the object. You draw this. Okay, I will do it like this. Okay, next is one ray is here. Okay, as you can see, if you draw them back, they go back and they will form a virtual image. So this is the case where if you keep your face here, your face will be enlarged. So basically it will help you to shave your beard, okay, or your the uncle which cuts your hair, it will be easier for him to cut your hair because he will see bigger image of you, right? So this is the case, and this is the last question of our discussion. I hope you enjoyed this session, and if you are still visiting a palmist to know your future, stop right there. What you have to do, you have to take the lens and look at here. Okay, Diksha Scholastic Aptitude Test, that is the best platform for you to know about your future, which is best suitable for you. Okay, every Sunday we are conducting DSAT at our Diksha campuses. You have to fill the form. And what is DSAT? DSAT is basically a 60-minute lecture session with a doubt clearing. Once the lecture and doubt clearing is over, then there will be aptitude test based on the lecture, and based on the result of the aptitude test you will be provided with a counselor. The counselor will give you the guidance based on your test result. Okay, and your competency, whether you are suitable for JEE or NEET or KCET, or you are not at all suitable for science, you should focus more on commerce or arts. So everything will be revealed once you are applying this for this test, and the link that is given in the description below, you can check. And I will be back with chapter review of this entire chapter review in our next week Saturday class, and Sunday there will be test on this chapter, entire chapter. I hope you enjoyed this session. I will be back soon enough. Till then, bye.